All right, let's take a look at 17.20, part I, where we're supposed to write the overall equation for a solution of cesium 2 sulfate electrolyzed in a cell with inert electrodes. So that means we need to figure out our half reactions for our anode and our cathode. I hope you know CPR, because you got reduction occurring here, and you got oxidation occurring over here. If we look, we're not going to find an oxidation reaction for cesium, and we're not going to find an oxidation reaction for sulfate. So that means our only oxidation reaction that we can possibly have here is going to be that of water. And that, of course, has a voltage of So what's our reduction going to be? Well, okay, so let's shrink up our anode so that we can focus on our cathode reaction here. Our cathode, we've got three possibilities, actually. So we've got quite a few possibilities for what's going to be occurring at our cathode. Our cathode, come on, pen, work. Technology is wonderful until it's not. All right. Our first possibility is going to be the reduction of cesium, of the cesium ion. Well, the reduction of the cesium ion to cesium metal isn't given in your textbook. Just to make sure I wasn't missing anything, I did look it up online. It's a negative 292 volts. Then we have to find the reduction of our sulfate, and you've used this one quite a few in the previous parts of this problem. So I'm sure you recognize that reaction right away. And the voltage there is a positive 0.17 volts. Our other possibility is, of course, water. And we have the reduction of water, and that is 2 water liquid and remember here we're dealing with electrolytic cells. That's really key to what we're looking at here. And that has a voltage of a negative 0.83 volts. All right, so we can rule this out because it's positive. So we're not going to be driving it by adding a current, which is what we're doing in an electrolytic cell. This is the more positive. So it's going to be driven by our electric cell first. So that's our other half reaction. So both our half reactions in this cell are going to be those of water. So basically we're going to be applying a big electrical current, and all we're going to be doing is reacting our water. So what is our water reaction going to be? Well, let's add them together and find out. We have 2 H2O liquid. Oh, that's supposed to be liquid. Tell you what, this stylus is not cooperating today, guys. Alright, we're going to pretend that's an L. And it's yielding oxygen plus 4 hydrogen ions. I think this stylus is ready for the trash can. Well, there we go. There was a piece of dirt trapped on the bottom. And to that, we're going to add Okay. Now, what we have to do is we have to add these two reactions together. Notice that I only have 2 electrons on the bottom reaction and I have 4 on the top. So I'm going to have to multiply through by 2. That gives me 4, 4, 2, 4. And then if I add these guys together, I get 6 water yielding oxygen plus 2 hydrogen gases plus, oops, there should be a negative there, 4 hydrogen ions plus 4 hydroxides. And I think this is where some people run into trouble, because what do we have when we combine 4 hydrogen ions and 4 hydroxides? 4 molecules of water. So we can combine those, form 4 molecules of water, and of those 6 water molecules, we can reduce it to 2, giving us a final grand answer for our overall equation of 2 water yielding 2 hydrogen gases plus a thing of oxygen.